Hey everybody, we're the co-founders of Inversion. We recently announced a new vehicle doing delivery from space in an hour, and Scott Manley made a video about it, so we're going to react to that today. Cool. All right, here we go.
Hello, it's Scott Manley here. On Wednesday night in Los Angeles, a company called Inversion unveiled a vehicle called the Ark. This is supposed to be a
So I made this mistake in the presentation. It's just Ark. Drop the.
Hypersonic lifting body cargo carrier able to deliver cargo of whatever sort you want to put into it anywhere in the world inside an hour, assuming that you actually have a satellite already lined up. I'll be honest, I didn't watch their stream live because I was at a pub quiz winning $50. It's not rocket science, it's a whole lot more difficult than that. Especially when the quizmaster doesn't understand that a meteoroid and an asteroid are technically the same thing. Anyway, later I did actually watch the preview animation showing the concept of operation. You have this little spacecraft in orbit. It's sort of a lifting body shape. There's some dude with a fancy laptop sending a signal to the satellite, which then jettisons its cruise stage, performs a 180 and then fires its engines. And I'm going to say, I think you should probably change the order of operations here.
So we actually do leave our satellite on orbit, and that's intentional.
Then fires up its onboard engine, slows down, and then starts descending through the atmosphere. And by the way, apparently this animation was done by the team behind Real Engineering.
Shout out, Brian.
So anyway, by being a hypersonic lifting body, it is able to maneuver, it's able to perform S-turns to control its range, to get cross range, to bring itself over the target.
So the hypersonic S-turns are both for controlling our downrange trajectory, right? You can bleed off speed as you do that, but it's also super useful for the actual hypersonic testing customers that we're going to be flying. So we're able to stay in that environment for a lot longer than other vehicles might be able to.
And then once it gets close, it can pop out a power glider and glide.
So technically this is a ram air parachute. It's a little bit different than a paraglider, but similar overall concept, steerable parachute system.
Gently down to its target on the ground. In this case, they're showing fires, and I guess we're supposed to imagine that there's some sort of disaster, and there are people on site that can take advantage of this thing's special delivery. So anyway, this whole design is a lot like...
So there doesn't necessarily have to be people at the landing site for the delivery to actually be super useful for our customers.
Like a cargo-capable version of the X-38 that was developed. And we've talked about this concept before because, of course, the US is talking about...
So X-38 is a super cool vehicle developed by NASA, supposed to be like an escape pod from the ISS during the shuttle era. And it landed under a very large controllable parachute. That parachute is actually so big it was nearly impossible to deploy and control. We get a little bit of benefit because Ark is much smaller, so we can use basically a normal skydiving parachute. X-38 is actually derived from an earlier lifting body reentry vehicle called SV-5D. Very similar, if not the same OML.
Very similar.
Yeah, and frankly, there was no advancement in lifting body aerodynamics or hypersonics from the early 60s all the way through the 90s when X-38 was developed. So we're excited to bring a new OML to bear.
Yeah, still stands that all of those X-plane programs, big inspirations for a lot of what we're doing, and we leverage a lot of the work that was put in by the many talented engineers back then, even in developing a more cutting-edge vehicle.
Rocket-based cargo systems. While everyone's drawing pictures of Starship, this actually makes a whole lot more sense. And so I figured
we agree. You know, using Starship for deliveries around the globe has its place. That it's super awesome. But being able to use Ark lets us land anywhere. It lets us land near people. So you don't need to have a massive clear area for when the Raptor engines would fire. And it's a very different size of payload, right? Think tactical level payloads rather than larger mass payloads with Starship. So we see this as a complementary family of systems for delivery from space.
Figured you guys might want to hear me talk about this, but also those of you who remember the old school days of this channel Well, I think you might like to see me do it in Kerbal Space Program, because that is something which very much made this channel happen. It gave me a platform to talk about stuff in space, and building something like this, well, your Kerbal Space Program's great at it. It also gives me an excuse to build a new install of Kerbal Space Program with black...
I would have thought that one of us would have been the first to build this in Kerbal Space Program, so this is pretty cool to see.
Black Rack's amazing cloud mods, the parallax graphics. The failure of the sequel has only meant that the mods for the original have become all the more important. So yeah, over the last few years, we've heard a lot of different companies getting involved in rocket cargo projects with DARPA. We've had sort of gone back and forth. SpaceX were obviously the favorite early on, but Starship isn't necessarily the best solution to the problems that they're looking at. The Starship is very big, and it probably doesn't land, in random places particularly well right now. The only places we've actually seen Starship land are either on its legs back at Starbase or in, like, the Indian Ocean. It's a vehicle designed for reusability, whereas when you're wanting to deliver a bunch of supplies to the middle of nowhere, you may not want to have something that can be reused.
So you mentioned how Starship can go and deliver, but maybe it can't land anywhere. And I wouldn't be surprised if SpaceX eventually develops that ability, but there'll always be places that you want a smaller amount of delivery. You don't want to draw as much attention. You don't want a large skyscraper landing. And Ark is designed to either be reusable and recoverable, but also cheap enough that you don't have to recover it if you don't want to.
We've seen a number of companies developing return capsules for manufacturing running experiments in space. That all makes plenty of sense, and they can be certainly landed with some level of precision because they're able to put them inside landing ranges. But if they can be steered through re-entry, then they can control their landing site with much greater precision. So that's where the idea of a lifting body begins to make much more sense, becomes much more attractive to as a service.
So there are kind of two concepts here around maneuverability and re-entry. The first is your landing precision, and then the second is how much range you can access with a single vehicle. The landing precision actually is really focused on our parachute system. That's where we get most of our precision from. And the aerodynamics of the vehicle allow us to glide to a very large potential area, so we can access many different locations. Ballistic vehicles coming back with non-guided parachutes, they need hundreds of miles of clear area to make sure that there's enough safety. That's just not tenable, right? We want to be able to land on one side of a road or another. So having this level of precision is important.
And while a lifting body could, in theory, have undercarriage and land on a runway, if you're potentially sending these to an austere environment where they can't clear several thousand feet of flat terrain for a landing vehicle, it makes much more sense to have it land under a parachute, under a canopy. And
that's exactly right. Our parachute system is designed to land in these really austere environments. Runways are not available everywhere, and so this allows us a lot of flexibility there. Also, landing under runway has a whole bunch of other considerations when you start talking about subsonic lift, you start building in landing gear, all sorts of things like that actually pushes this closer to something that looks a lot more like the space shuttle in its design. Our vehicle looks unique in the fact that it's designed with particularly that hypersonic maneuverability in mind, and not necessarily having to land on a runway because of our parachute system.
The idea of having a paraglider that can deploy and then steer it gently down to a very precise landing site, that's where this starts to make sense. Now, as I said, the X-38 was a spacecraft which was being developed for the International Space Station. It was supposed to be a return vehicle, a life pod or escape pod for astronauts. And it would also use lifting body to glide to a broad location. And then once it had slowed down enough, it would deploy a paraglider and land with some precision. So this combination of features, as we said, it's been talked about before, and it's the one that always made the most sense for rocket cargo. So seeing a company taking this and then saying, actually, we would like to do something even more crazy. They would like to have a mega constellation of delivery ships already with the cargo on board. And hypothetically, if you had enough satellites up there, you would just find out which one was going to have a pass within its cross-range capability, then order it to fire its engine so it would come down over, and then it would guide itself down and land the cargo exactly where you want it to. And by the way, yeah, this parachute, this paraglider in Kerbal Space Program is way overpowered. It's part of the Kiness.
So why have a constellation, right? Why not launch just directly whenever you have a need? The key thing this comes down to is availability and response time. If you need to have a rocket that's waiting and ready to go, that can work for some payloads, but there's a lot of missions that you don't want to have to rely on having a rocket that can be stood up, fueled, and launched in time. So pre-doing that, pre-deploying those into a constellation, give our customers the ability to call them down whenever and wherever they need, without having to rely on launch being available at the time of need.
Mod and should not be considered realistic at all. So how big a constellation would you need? Well, imagine you have 1,000 kilometer cross-range capability, left to the right of your orbit. If you consider that the circumference of the Earth is about 40,000 kilometers, that's 2,000 kilometers per spacecraft, and then of course you have to account for inclination. It's no more than 20 planes of satellites. If you want to have 1 hour delivery, you would need at least 2 satellites per orbit. So for one specific product, you would need about 40 spacecraft in orbit.
So surprisingly close, actually. One of the key things that to think about is, because it's an orbital plane and you're taking the circumference of the equator, you actually get to count it twice, because both on the front side of the Earth and then on the back side, that same orbital plane is accessing the equator. So we think you might be overestimating it just a little bit.
And then that means, in theory, the first one could come within an hour, but then you could have up to 40 over the next 24 hours. And the kind of payloads that they talk about carrying, well, they put up this nice, slide showing a list of things, and that list seems to go on forever, but actually, if you look very carefully, they just loop it.
And it's a good catch.
And I am sure that if you ask the US military, would you like the ability to deliver this equipment anywhere in the world with 1 hour's notice, they would say yes. And then you would tell them the price, and they might think a little longer. They had a great little video showing.
So just to talk on cost for a little bit, for everything, right, it's about the value you're able to create. And what we're doing here is actually replacing an existing very expensive strategy, which is dotting the cargo all around the globe in hundreds of different warehouses. So our analysis shows that we're actually cheaper than what's happening today.
Showing the precision guidance of their paraglider systems. They basically drop a couple of them off the back of a plane, and then they choose to glide down to the individual target sites. I think it's interesting that they flew 2 at the same time. I guess
it's an interesting call out. So we have the ability to drop multiple at the same time. It gives us more time under canopy, and also is useful when you're starting to look at different situations where you might be delivering multiple different types of cargo or things like that into the area. But plenty of our drops do with just one drop as well.
Guess, they're imagining a future where you have multiple of these things all coordinating and coming down together. And of course announcing their arrival with sonic booms and big parachutes. I'm not sure how reliably this could be put into an area where, the area was not secure, but as they show at least they can put these things down with some precision. I don't doubt.
So that's an interesting call out. Can't really go into it too much, but we're thinking about it.
Doubt that these kind of vehicles could be built, and that the team has the ability to do this. It sounds like they've got fairly talented people in there. The question really is, would the US spend a lot of money building this and flying this? Like, given the size and the mass of the spacecraft, I wouldn't be surprised if you could put, say, a dozen of these on a Falcon 9. So it would only take a handful of launches to build out a full constellation for a specific item. But then, of course, you need to keep on delivering replacements every 5 years.
Yeah, so it really doesn't take too many launches to go and have a fully operational constellation. That's one of the key things with this architecture is we don't need thousands of vehicles, and we don't need hundreds of launches to have it operational. And thanks to the reusability, we're able to go and refly them after that 5-year life on orbit.
Now, instead, you could do a launch on demand system, But again, you have to be concerned about the possibility of a cargo launch being mistaken for a ballistic missile launch. They are going to be pretty much indistinguishable. And indeed, a re-entering vehicle is going to be essentially indistinguishable from like a hypersonic glide warhead, which is designed to target a specific area. So if the US was to deploy such a system, they would probably have to have some interesting diplomatic agreements whereby they probably would let other nuclear powers verify that they weren't actually putting nuclear warheads on these things.
So an important thing on trajectories, Scott mentions that he thinks the trajectories to be quite similar to other trajectories. In our experience, it's actually not the case. It's very meaningfully different of a trajectory we will fly for our delivery missions. Our goal is to slow down. Our goal is to land. And so we fly a very different guidance scheme than what others might.
Every now and then, the US has talked about putting conventional warheads on ICBMs, and this is always the situation that they come back to, that they can't really do that because it could be mistaken for a nuclear warhead, which has very bad consequences if your adversaries mistake your conventional weapon for a nuclear strike. And so after the animations, the promises of 1 hour delivery worldwide, there was one interesting thing that actually does give them a real business case, at least in the near future, and that is they've signed a substantial agreement with Kratos for hypersonic testing, because their vision of their vehicle is going to be sitting in hypersonic domain for a whole lot longer than a lot of the other options.
So Scott's totally right. Ark is unique in its ability to do hypersonic testing because of its maneuverability, and that we can fly trajectories that keep us in the hypersonic regime for much longer, in a much more controlled way, able to tune the trajectory depending on what the customers want to go and test.
Of course, they have to actually get their vehicle working, which will be a bunch of hypersonic testing in and of itself. Now, the design, it just is sort of your standard lifting body shape. There's not really any fins. There are a number of flaps at the back which control the airflow coming off the rear. It looks like there's an offset center of mass, which gives them a pitch up moment. It looks a lot like the European Space Rider concept, which has been tested, has flown to space and come back, demonstrating control capability. So between that and the X-38, there's actually a whole lot of heritage that at least inspired the design. They're not starting from zero with a completely blank slate.
That's totally right. We leverage a lot of the great work that was done on those previous programs to not only for inspiration, but actual technical details, flight data, all sorts of different things go into designing this.
They also previously flew a return capsule on a transporter mission. They flew like a standard, non-guided capsule called Ray. And so Ray was a whole lot smaller. It was about 63 kilograms. And unfortunately, they had some technical issues. They were unable to get to test their re-entry, so it is currently still in orbit, still in sun-synchronous orbit. And I'm guessing it's decaying, and at some point it's eventually going to come home. But as of, right now, literally right now, it is still orbiting the Earth.
Yeah, so Ray is still operational on orbit. We have full control of the vehicle and leftover propellant, so we're able to do maneuvers. It was a very successful first flight for the company. We built basically every system in-house. As Scott mentioned, unfortunately, we had a small failure of an electronics component, an off-the-shelf electronics component. It meant we couldn't ignite our rocket engine to come back, but overall, really good learnings for the company.
So the way I see it is they've come up with this presentation for the technology they want to develop and get investors in on it. It seems to...
One quick note is this is not us asking for permission to go and develop it. We are mid-development. We've put a lot of effort into designing this, and this vehicle is not just a concept. This is actually becoming a reality.
Sort of dovetail nicely with the US's space cargo transportation or rocket cargo transportation endeavors. But I won't be surprised if what they actually end up doing with it changes a whole lot more, because I'm not convinced that the constellation idea actually makes sense. It does make sense if you have way too much money, and we all know that the US military has a lot of money. And the US military,
So at kind of the core of what Scott is saying here is this too expensive, right? Is it actually worth putting a constellation up of these? And it's a really interesting point and something that we think about a lot. 5 years ago, absolutely not, right? It was too expensive. It's only now that Falcon has been flying regularly and costs have come down that it actually makes sense to go and do today. And 5 years from now, it'll make even more sense. We're already spending so much money to have this cargo around the globe. It just happens to be stored terrestrially. And so we're able to take that cargo, put it in orbit, and actually store it cheaper than what it's done on the ground right now today, let alone 5 years as we add reusability and the launch industry continues to drop costs.
A lot of people don't quite appreciate that one of the things the US military is most capable of is logistics. That is like its superpower. Sure, it has all sorts of interesting aircraft and weapon systems and things like that, but it has the ability to move all these military assets and other assets using military, transportation across the world to where it's supposed to be in relatively short order in a way that other, armed forces really can't compare. And so if you're to ask, like, what is the innovation in logistics that might, make a difference in the next conflict? Your rocket cargo sort of still fits into that, even if it does seem far-fetched.
We completely agree with this. If you go back 100 years, the aircraft made the difference in logistics for the U.S. military. It allowed for broader reach, faster reach to remote areas. That's exactly what our vehicle does, but at an order of magnitude faster, right? It is that next step in transportation technology that allows for global access, broad logistics, all while being feasible from a cost perspective.
And as a player of another video game, EVE Online, what that game taught me was that while individual battles can be swayed by the right fit, the right tactics and stuff, the things that ultimately win the wars are the logistics that brings everyone to the right place where they're needed. And that's why I won't be surprised if on future battlefields we do in fact see vehicles like this with large power gliders delivering cargo that took off less than an hour ago from halfway across the world. I'm Scott.
We think it should take off years before it's needed and then just be delivered down from orbit. It gives this pre-positioned nature that it's always ready to go. It's constantly waiting to be called down and is there when you need it.
I'm Scott Manley. Fly safe.
Bro, absolutely iconic. So thank you for joining us to react to Scott Manley's video about our Ark vehicle. Scott's an absolute legend. We've watched him since before we were even thinking about becoming an engineer, and really enjoyed this. Hope you had a fun time and learned something.